So hello, in this video I will be discussing Codeforces round 1003 rated for division 4. So I will be discussing first problem till E. So let's get start with problem number A, that is this problem. Okay. So in this question we are given a string and we are given two forms, singular and plural, right? So initially we will be given a string in its singular form, which means the the US string will be appended in the end of my string. Okay, then for example you can see US is appended in each of the string, right? So what we have to do, we have to just replace US with I in each and every string and just print it. So yeah, that's the only thing to do in this question. You can see, just remove US from the string and put it I in the end. So I think so most of you would already be able to do this question, as 30,000 submissions are there. So yeah, so you can see the code is also just print the string till n minus 2 and print I in the end, right? So moving on the next question, that is Skibidus and Ohio. So in this question we are given a string again, like okay, done. Now what we can do, we can replace we can okay, first of all we have to find a set of two characters such that the adjacent characters are equal. Okay, which means like a s of I should be equal to s of I plus 1. If if we are able to find such this such of pair, then we can replace the first value with any of the character, right, and remove the second one. Okay, you can see, like replace the s of I with any lowercase written character and remove the s of I plus 1. Okay, done. So we have to tell them what is the minimum length of string possible, because you are also removing, right? So the length of the string will be decreased, right? So what is the minimum length possible? So if I say you, like if I'm having one such pair of two adjacent pair, then answer is 1, else answer is n. But how? Let me show you here. For example, I'm taking a random string like a b b c b, like c d, and let's suppose e. So answer to this is 1. But how? Okay, so first of all, I'll tell you. Let's suppose I is also there. Can you replace these two C with the previous one? Yeah, I can replace these two C with B. Okay, done. Can I replace these two B with previous one? Yeah, I can replace these two B with C. Okay, done. Can I replace these two C with B? Yeah, I can replace it again B. Again, I'll replace these two B with another B. Okay, replace these two B with another A, because A is behind us. Okay, I'll replace it. Now I'm having A, and what is the end? That is E and I. Now I'm having again two characters, right? I will replace these two characters with E. That is next one. Okay, I'll replace it E and I. I'll again replace E with I. Okay, I, and I'll replace these two with single any other character. So you can see the answer is 1. So this is the only case in this question. If there is one pair, one adjacent equal pair in the string, then answer is 1. If none of the adjacent pair are equal, then answer is n. You can see the code. The code is also easy. I'm just counting, like if there's only one such pair such that s of I is equal to s of I minus 1, which means adjacent are equal, then simply print 1, else print the original length of string, because you cannot even perform a single operation. Okay, so yeah, let's now get to the problem version, that is C1. This is an easy version. Okay, let's now read the. In this question we are given m is equal to 1, but in hard it is m is not equal to 1. Okay, what is m? So we are given two arrays a and b. A is of length m n and b is of length n. Okay, done. Now for each integer I from I to n in array A, we are allowed to perform at most one operation. Please read this carefully. For each index I to n, which means on each and every index I can perform operation at least one. Okay, okay. Now but they are also saying, what is operation? Operation is simply just pick an integer j and set a of I is equal to b of j minus a of I, the j which you just selected, right? So our goal is to make the array non-decreasing. Okay, which means it should be increasing. So we have to tell them whether it is possible or not, just print yes or no. But how to solve this problem, right? So I'll tell you. Okay, so if I'm taking this example, let's suppose 5, 4, 10, and 5. And what is the okay, I'll take a word yes, yes wala case. Okay, so I'll just now write 1, 4, 2 and 5. And what is my m? M is only one number, that is 6, because it is easy version. The length of another array is only 1. Okay, 6. So how to deal with it? Now there are two cases. If my current number is, like, this is the last number, right? But you must be thinking we cannot perform any operation on the last number. But this is not the case. There is a possibility that we must apply the operation on the last number. But why? If we are able to make the last number bigger than its current value, then it is beneficial to me, right? So, but in this case, you can see the 6 minus 5 is 1, which means in this case it is not beneficial. But let's suppose it is not 6. Let's suppose it is uh, 15. Okay. Now, whether it is beneficial for 5 to take the operation or not? Yes, it is, because 15 minus 5 is 10. And if you replace 5 with 10, it will be beneficial for my previous array, right? Because it is now become more larger. Now the previous number has some threshold to adjust in, right? So that's the case. So in this particular value, you will not perform the operation, because 6 minus 5 is decreasing its value. I'll always try to increase the value of the last number. Okay, so I'll go to next number, that is 2. So tell me whether my 5 is smaller than 2, whether my 2 is smaller than 5. Yes. So should I perform the operation or not? Ideally, if I show you, you should perform operation. But why? Like, if you are not performing operation, it is 2, right? But if you are performing operation, it will be 6 minus 2, that is equal to 4. And 4 is also smaller than 5, right? 4 is also smaller than 5. If such cases arises, if such case arises, which means using the operation is making the value bigger but smaller than the next number, then you should choose that operation. Okay, I'll replace it with now 4. Now tell me whether should I perform operation on 4 or not. You should not perform, because it is smaller than equal to. But why? Because you have chosen an operation of this. If you had not chosen the operation on these two number, then you might find the number, you might not find the number, right? So always try to increase the number as greater than as large as possible, such that it is smaller than your next value and it is greater than your current value, right? So yeah, I'll perform the operation, and you can notice my answer is yes, and I can sort the array in increasing order, right? So what's the catch? Catch is simply, I'll always try to increase my number. I'll always try to increase my each and every number, such that it is greater than my current value and smaller than my next value. If such case is not possible, which means, like, if 5 is smaller than 2, right? uh, if this is my array 5 and 2, and I am having number as 3. You know one thing, 3 minus 2 is 1, right? It is decreasing the number. So you don't have to worry, because 2 is already smaller than 5, right? But if uh, like it is, I'm hoping it is 4, it is 5 only, right? So 5 minus 2 is 3, right? So if you replace 2 with 3, it will help your previous array, right? It will help you this part of array. So you will take the operation as 3, right? But if you're not able to make the small, you don't have to worry, because it is already smaller. You are trying your best, such that your next part of the array don't have to struggle much, right? Hope so you are getting the point which I'm telling to you. So yeah, I'll show you the code also. First of all, I'll check whether I can increase my last number or not, because it will decrease the struggle of my previous array, right? So if I'm checking if b of 0 minus a of n minus 1 is greater than my current a of n minus 1, then I'll take the operation. Okay, done. What I'm doing next, I'm checking if my current number is greater than my next number, which means I have to perform operation. If I'm not able to decrease it, then I'll have to print no. So I'll just make the operation, because it is already greater than, which means let me my 4 is already greater than 3. If by choosing the operation I'm not able to make it smaller, then by default my answer is no, right? Then by default my answer is no. Else, what I'll do, I'll just decrease my value and move on the next value, right? But if my current value is smaller than my next value, then should you perform any operation? Yes, you'll always try to increase the number. I'm just checking if the new number which I will get, that is x, b of 0 minus a of I, is that number smaller than or equal to my next number. Yeah, remember this condition, this is also important. If it is not followed, then you'll lose your whole question, right? Just check if this value is smaller than your next value, and it should be greater than your current value also, because that's the main point of doing this, right? So just replace the value and print it. If using these whole operations you are able to bypass the loop, then print yes, else print no. Yeah. So this is explanation of C1. Now we'll go to expansion of C2. Okay. Now in this question, the question is also same, but you now having multiple values to deal with. Okay. Let me take an example. Mm, okay. Let's now choose this one. That is 2, 4, 2, 8. Okay. 2, 4, 6, and 5. Okay. And next is 6, 1, 8. Now tell me, this is array A, this is array B. This is the array from which you have to choose the numbers. Now tell me whether the sequence of this number matter or not. The sequence of this array does not matter. So I'll just replace this array with 1, 6, and 8. I'll tell you why I'm doing this. Just sort the array. 1, 6, and 8. Okay, done. Now tell me, let's suppose you are having two numbers x and y. These are the adjacent pair of an array. If your x is greater than y, okay, done. Now you have to choose an operation, right? You have to make an operation. But what operation to make? Let your operation be, let's suppose the number which you are choosing from array B is a. Let's suppose it is p. But now what you have to justify that such that p minus x should be smaller than your y, smaller than or equal to y, right? This is the thing you have to just which you have to satisfy, right? So if I simplify this equation, it will become p is smaller than or equal to x plus y. Okay, done. Now is this looking familiar? Now you have to find you have to find the largest number which is smaller than or equal to x plus y. Or or if I say is in easy terms, you have to find the largest number which is smaller than the sum of adjacent pair, such that adjacent pair is not following your decreasing order. Okay, done. But how to find this number? Now you remember I have tell you to sort the array B. Now remember, sorting the array, finding the number, it is now leading to binary search. Just simply use the lower bound function and find the number, which is find the largest number which is smaller than which is smaller than or equal to x plus y, using the lower bound in C++, or you can use any other function in Java or Python. Yeah, but it is familiar to you. Okay, done. Now what is the number? Let's suppose 5. And one more thing to remember in previous question what I tell you, I will also try to, let's suppose it is x and it is smaller than y, it is smaller than y, but in that case also I will try to increase my y, such I will try to increase my x such that it is greater than x and it is smaller than y. But let me just simplify, it is the same equation only, such that p minus x should be greater than equal to y, and it should be greater than, and let's suppose it is greater than x. Okay, done. If I remove this, you can easily understand it also. Let if my p is let my then my p should be greater than smaller than equal to x plus y, right? So hope so this is justified to you. So in each and every case, if your x is greater than y, then you have to find the largest number which is smaller than x plus y. If your x is smaller than y, which means there's no need to perform an operation, but for decreasing the struggle of previous array, you will choose an operation such that it is beneficial to you. And what is the benefit? Such that your next number should be greater than x and smaller than y, because increasing the x will help the previous array. And use the lower bound function for making the operation to finding this p value, that is x plus y smaller than equal to p, right? If I show the implementation, that is also easy. First of all, first of all I'll take the array A, and you can notice I'm using a set to get the to remove the duplicates and sort the array. Okay, just taking the input in the set and converting back it to a array, right? You can also use a lower bound function on set, but yeah, just for simplicity I'll use array. Now performing the operation on the last index because it is necessary. uh, just checking if your b of, because you will now choose a biggest number, right? If your biggest number minus your last number of array is greater than your current number, then you will choose the operation else you know. Now what I'm doing next, if my current number is greater than my next number, which means I have to perform operation. If I'm not able to make it smaller, then just print no and return. But what is the operation? I'll just find the sum, that is value a of I plus a of I plus 1. Okay, done. I'll find the lower bound, which means largest number, which is smaller than my x plus y, that is p, right? This p. I'll find this p in my array B, because this is the array whom I have to select from. Okay, I'll set the index. Okay, I'll check if my index is these are some conditions you can notice, like you can check. If your index is 0, which means you're on the first index, and your number is greater than your expected value, yeah, right, your value, if I tell you the behavior of lower bound, if none of the value is smaller than your current value, it will give you the first index of the array. Okay, that's why I'm checking for the first index. If it is the first index and my value is greater than my expected value, then print no, because you cannot make it smaller, else just make the operation and continue. But if it is not the last index, you can also consider the previous value, right? You can also consider the previous value. If your current value is greater than your expected value, then you can expect that your previous value is smaller than your value. That's why lower bound returns you the greater value, right? Just perform the operation, and this is the standard case. In this case, it's just simply your b of index is smaller than or equal to value, which means this is the thing which you are finding for, right? But the main difference between this part, if this part and this part, I'll tell you. In this case, it is necessary to perform operation because it is already greater than your next value. But in this case, it is not necessary to perform operation. You can notice the things. I'm just doing the same thing, like finding the index. But you can notice I'm not returning it here because it is not my necessity to perform operation, right? You can notice I was returning over here because it is greater than my next value, but I'm not returning over here because it is more than my value, and it is not my necessity to perform operation, right? And one more difference. In uppercase, you were blindly making the operation, right? In uppercase, we were blindly making the operation knowing that it will make the value smaller. But in this case, you will choose greedily. If and only if it is making me beneficial. What is the benefit to me? That my next value should be greater than my current value, and it is already smaller than my next value because I'm taking a lower bound and that value part. This is the same logic over here also. By taking the value, it will be automatically smaller than my I plus 1, but I have to also check it is it should also be greater than my current value. Then only I make the operation. You can notice this is the one extra condition in each and every case of the operation, right? So yeah, just check the conditions and print at the end yes if you're not able to, if you're able to bypass the loop and not able to hit this particular no, right? So hope so the explanation is clear to you. I'll just now jump to next problem, that is D. So in this question, we are given some couple of arrays, okay, done, and we are given a score of array. What is the score of array? The score of array is the sum of each and every prefix array. Okay, hope so it is clear to you. The sum of an array is sum of each and every prefix array of your current array. Okay, done. If I just justify it over here, let's suppose these are the numbers of array. The sum of your array, the score of your array would be sum of this part plus sum of this part plus this part plus this part and sum of this part. Okay, hopes you got it, but it is score of your array. Now we are given some couple of arrays. Now we have to arrange this array in some order. Okay, we have to arrange this array in some order. For example, first I'll choose first this array, then I'll place this array in front of my this array, right? And by choosing some particular permutation of this arrays, you cannot intershuffle this array, right? You can only change the order of occurring of this array, right? For example, this third array should come after second array, this first array should come after third array, right? So this is the operation. Now after performing this operation, you have to tell them what is the maximum score possible. So if you notice one thing, in this pattern, if I draw it clearly, first I'm taking this, second I'm taking this, third I'm taking this, fourth I'm taking this, and fifth I'm taking this. Now to maximize the score of your final array, now to maximize the score of your final array, you want the maximum number to be most occurring, right? For example, your 10 is a maximum number. You want 10 to be most occurring number in your whole sum, right? But how you can do that? If you notice this pattern, your first number is occurring most number of times in your whole sum. Or I can say in every sum it is occurring. Similarly, my second sum is occurring in second place, right? And similarly, my third number is occurring at the third place in each and every sum, right? Which means keeping the highest value at the start is beneficial to me, right? Keeping the highest value at the start is beneficial to me to increase the sum. So this is the only hack to this question. Just find the sum of each and every question. Just find the sum of each and every array. The array with the maximum sum would be at the first, the array with the second maximum sum would be at the second number and similarly follow the order. If I show the code is damn easy. Just take the input array, okay, find the sum of each and every array and append it in your array, that is count is sum and I is index of the array. I'll just sort the array in reverse order, which means the highest sum will be my first sum. Okay, I'll just iterate on my sum, and the second part is what is the term which I appended in the second, that is the index. You can see index over here. Okay, now with respect to index, just append the array in your final array, okay, done, and find the sum of your final array, right, and just print the answer. So this is the only problem, not the level of D, right? But yeah, now I'll discuss the E problem, that is E, Skibidus and Rizz. Okay, in this question we are given a binary string, okay, done. Okay, in this question we are given two numbers n and m and another number k. N is number of I think so it was zeros only. uh yeah, n was number of 0, n is number of 0, m is number of 1 in your binary string. And what is k? K is your, let's suppose in your binary string you are having n number of zeros and m number of ones. Okay, done. Let's suppose this is your binary string. I'm just making it as a some random box, but yeah, like, so if you choose some substring in this binary string, okay, done. Now if you calculate the number of ones and the number of zeros in that particular substring, let's suppose that is x and y. Okay, now what is k? K is maximum of or if I say you, let in simple terms, it the number of zeros are x, number of ones are y. Your k is simply absolute value of x minus y. Okay, this is your k. Okay, done. Now what is question asking you to do? You have to construct a binary string from the given number of zeros and ones such that the the maximum score of any substring is k, right? Which the let me repeat, the maximum score. What is the score? Score is simply this part, the number of ones minus number of zero, the absolute value of that, right? The maximum score of your subarray should be exactly equal to k, right? For example, let's suppose you are having total 5 subarrays in your string. I'm taking a hypothetical case, and one of your and the maximum score is, let's suppose k, it is 0, let's suppose 3, and all the numbers are smaller than k. You can notice it is exactly k. But if the maximum score is k minus 1, then it is not the answer. Or if I take, let's suppose your k is 6 and and it is also 5, you can see the maximum score the maximum score here is 5. Then this is not the case. The maximum score should be exactly 6, right? Exactly k. Or so how we can solve this problem? This is also a easy problem, but let me tell you how. First, check couple of things. Let's suppose if your initial absolute value of n minus m is greater than k, can you tell me, can you make the answer? The answer is simply, can you find the answer? The answer is no, because in your full binary array, the number of m's and n, the number of zeros and 1 will be equal to n and m only, right? So if you find the answer in that case, that is n minus m is greater than k, then answer is absolutely no, right? So the only condition to check in this is this only, right? So if the score of your final binary string is greater than k, then simply print no. But what else in other case? The another case is also easy. Just find the most occurring character, that is 0, either 0 or 1. Okay, done. I'll find, let's suppose in our case it is 0. I'm taking hypothetical numbers like it's k, let's suppose it is 3. Okay, done. And my n is, let's suppose 6, and my m is equal to 8. Okay, done. Now how to find, but if you how to generate the string? The generation is also easy. Just print the maximum occurring character k times, that is 1 in this case. I'll print k 1 1 1 times. Okay, done. Now it is reduced to 5. Okay, done. Now just print the alternating numbers 0 1 0 1 0 1. That's it. That is the only answer. uh, Now you can notice 1 is over here, so I'll start with 0 because it should not be equal to 4. Because in that case, if I write 4 over here, then this whole become a substring, and the answer my answer would be 4, and which I don't want. I want exactly equal to 3. So yeah, now I'll write 0 over here. It is now it will decrease to 5. I'll write 1, it will 4, and I will write it 0, it will 4, and just carry on, right? Until your sum n exhausted, just start printing another number. Okay, hope so. You have got the solution. So I show you the code also. Just take the input array. If your absolute value is greater than k, the condition which I showed you here, if your absolute value is greater than k, just print -1 and return. And yeah, okay, yeah, this is also one more condition. Remember I told you to print the largest number k times, right? If your none of the numbers is none of the if your both of the numbers are smaller than k, then can you get your answer? The answer is no. So just simply check this also. If maximum of n comma m is both smaller than k, then print -1 and return over here. Okay, done. Okay, now what to do next? If my number of zeros are greater than number 1, then just print the zeros k number of times and start printing the zeros and ones alternatingly. You can see the count variable over here. If count is 0, just print 1. I'm just replacing count with 1 and 0, 1, just swapping between 1 and 0, right? So if you're any number exhausted, just start printing another number, right? So this is the only case. And similarly case if your ones are greater than zeros, just print the 1k number of times and repeat the process for the same, right? So you will get the code in the description, and hopes you like the video. And I know this is the video got delayed. Yeah, I was not giving the context from these many days, but yeah, like please do comment if you have any doubts, and stay tuned for the next one. Thanks, bye.